Hello everyone and welcome to first part of my video series that I've decided to make about a light fixture that I'm working on, and this one has been in making for something like 8 months, and now I'm confident that I would finish this thing and achieve the goals, because this thing should be quite unique. The goal is to make a light fixture that produces 1 million lumens for the purposes of like strobe light or a blinder light for theatrical or like concert performances. And it all started with in the moment then when I got my hands on a huge load of LEDs. These are LG's 5630. They are mid-power LEDs for to be run with current up to 200 milliamps, so it's like half a watt class of LED, but they are really good quality and extremely reliable and efficient. I've tested them at half an amp, which is more than 2 times what they are rated for, and they lasted with good cooling for a good few days, and then I got bored and decided that these LEDs are worth saving, because these LEDs do not normally come in the back like this. They come on a reel, and the origin of these LEDs, how I got them, is at an assembly line. One of 1,000 or 10,000 LEDs is rejected by the machine, sometimes because it has a speck of dust on it, or some measurements of the LED are not right, because the quality checks in the production of LED PCBs, they are strict, and there are many, and maybe 1 of 1,000 or 10,000 gets rejected, and because the LEDs on the board have to be all the same color bin and all the same voltage bin, and when they get rejected, no one knows exactly what they are, so they can't be used. And these LEDs have been accumulating for quite a long time, and nobody really knew what to do with them. So I had a special PCB designed. I've designed it with my friend, and he helped me to get the pads and the stencil right, and then I had them manufactured by PCBWay in China, and they turned out great. This PCB is really unique. Is 17 LEDs in series like this, and there is also a place for resistor, and there are 32 rows of LEDs in parallel. Total it's 544 LEDs on one board with 32 resistors. The PCB is aluminum core PCB, which has really good cooling capabilities, and it's kind of needed for this purpose, because this board has maximum working current 5 amps, and the voltage it works, it's about 50 volts, So this PCB can consume 250 watts of power, and it also has great efficiency. This PCB at 1 amp has 160 lumens per watt, and at some 3 amps I measured it, it is something like 145 lumens per watt, so it's much better than cheap LED COBs, like COBs, like this one, and this is no more than 80 lumens per watt, and also quite unreliable. So the way you go about picking and placing this PCB is those LEDs is that you apply a solder paste through a stencil, and then you individually pick and place every LED on its position. It's quite a tedious job, and usually it takes something like 1 hour for one PCB. So I've outsourced this work and employed my family. I had quite a lot of LEDs. This is the rest that I have, and I've produced quite a lot of PCBs. And this is 26 PCBs. It's really a huge load of LEDs. They are heavy. The number of LEDs on this board is quite insane. Some 10,000 LEDs probably. Huge load. As you can see, the LEDs on the board are every single one of them, they are different colors, because the more orangey ones, they are the warm whites, the yellowish ones are cool whites, and so there are also CRI 90 LEDs, the like milky ones mixed in, not many, but they are in there. And when I connect this thing up, you can see it lights up quite evenly, but also a complete checkboard, because some are warmer, some are colder. Hope you can see it well. Some LEDs are a bit dimmer. No big issue, mostly the CRI 90 LEDs, and I was really happy with the result. The resistors in the series lines, they are 10 ohms, which turned out to be a good choice of a value resistor, because the currents in those series rows are quite well balanced, no more than 20% difference in current. The current is could be different, because some LEDs could have lower forward voltage than the LEDs in the next row, so it's the resistors helped out with keep sharing the current between the LEDs. This is currently at 42 volts and 10 milliamps. I could give it a bit more. When you give it some power, then the differences between the LEDs become much less noticeable. This is some 20 watts, and the efficiency of this module is great, and at 20 watts it's already putting a lot of light, but it could go much higher. And this is 2.5 amps, 3.5, 4, 5, 5.1 amp and 200 watts. The PCB is getting quite warm, but it puts a lot of light, and I'm really happy with the results of this PCB. So I've made quite a few of them, and these PCBs are gonna get lined up with each other in rows like this in a final light fixture, and there are copper bars running across like this, and the PCBs are connected to the copper bars because there will be some quite big currents. Okay, so I told you about the LEDs, about the PCBs, and I think we will keep the other subjects like the power supplies. They are very fun part of this exercise, and the fixture itself, which I have one piece already made, so I think you would like to see that. And let's leave it like this, and thank you for watching, and goodbye.